Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is Naim bin Ibrahim. My metric number is 2413011787. I am from group 31 and today we are going to talk about Ohm's law. First and foremost, our team members consist of Husna Fazana, Naim bin Ibrahim, which is me, Jasitaran, Kevin Seven, and Los Marvel Ransley. In this video, we are going to discuss about the definition of current, voltage, and resistance, the difference of current and voltage properties in series and parallel circuits, the relationship between current, voltage, and resistance using Ohm's law, and finally, we will show on how to use Ohm's law to calculate for current, voltage, or resistance. Ohm's law states that the current through a conductor is directly proportional to the potential difference across it, provided the temperature remains constant. The formula that we are going to be using in Ohm's law is V equals to IR. V is for voltage, I is for current, R is for resistance. For further clarification, we can use the analogy of a water hose. The water pressure acts like voltage. The harder you turn the faucet, the more pressure the water has to flow through the hose. Voltage is like that pressure that pushes electricity through the circuit. As for the water flow, it also acts the same way as the current. The amount of water flowing through the hose is like the current. It shows how much electricity is moving. For the resistance, we can imagine it as the size of the hose. If the hose is really small, it is harder for the water to flow. Resistance is like that. It makes it harder for the electricity to move. Voltage, measured in volts, is the pressure or push behind the flow of current. It is also referred to as potential difference. A voltmeter is used to measure voltage. It is placed parallel to the components to measure the voltage in a circuit. We will talk about this more in our example. In this example, I will show on how to find the voltage in each resistor using a voltmeter. As you can see, I have connected the voltmeter parallelly to each resistor to find the voltage value in each resistor. As you can see here, the voltage in this resistor is different. This is because of voltage drop, which means that the voltage that flows through each resistor decreases in value. And if you add all of this value, we should get 5 volt. As for parallel, it uses the same approach using the voltmeter, which is connected in parallel to the component. As we can see here, the voltage in each resistor is the same in a parallel circuit.
Good afternoon. My name is Jasitaran, son of Loganathan. My metric number is 2413028885. So now I'm going to explain about the resistance. The resistance usually measured in ohm is a measure of how much a material observes the flow of electric current going through it. So after this, I'm going to explain more about the resistance and the way of calculate the resistance by ohm meter by using the platform of Interget. Now I'm going to show how to measure the resistance series and parallel circuit. To measure the resistance, we must have the multimeter to find the resistance. These are the multimeters I'm going to use. So then we cannot measure straightly the resistance because the resistors are connected in series circuit. So firstly we must do is to separate the resistance in different parts. So I'm going to separate the resistance, and then we can start the stimulation. The resistance is ohm. The first one is 1 kilo ohm. The second one is 2.20 kilo ohm. The third one is 3.10 kilo ohm. Now I'm going to show how to measure the resistance in parallel circuit. The parallel circuit also seen. Firstly, we must use the multimeter to find the resistance. So firstly, we must separate first the resistance. If we not separate the resistance, we're going to show it will show the error. So we must separate first the resistance in different parts. For example, okay, if we run, it shows the exact resistance. Oh, the first one, second one, third one is the same 1 kilo ohm. I fix it. So I am using the red color wire in positive and the black color wire in negative. It will show the exact value of the resistance. Thank you.
Assalamualaikum. My name is Husna Fazana binti Ahmad Fuad and my metric number is 241301786. I will be explaining on how to measure and calculate the current in a series and parallel circuits. Current, measured in amps or amperes, SI unit A is the rate of flow of charge in a circuit. This flow is in the form of electrons flowing through a circuit. An ammeter is used to measure currents across each resistor. First, series circuit. To measure the current across each resistor, we need to break the circuit by lifting one leg of the resistor. As we can see here, connect the multimeter positive at the resistor and negative to the circuit. The multimeter will act as a connection to the circuit and make a complete circuit. To calculate the current, we will use I equals to V over R. I total equals to V over R total, so we get 758 microampere. The current across each resistor in a series circuit is the same, so we get I total equals to IR1 equals to IR2 and equals to IR3. To measure the current in parallel circuit is also the same. We need to break the circuit by lifting one leg of the resistor, but for parallel circuit, the current across each resistor are different, as we can see on the measurement of the ammeter. To calculate the IR1, we use V1 over R1 and we get 10 milliamp. For IR2, V2 over R2, we get 1 milliamp. And for IR3, V3 over R3, we get 4.55 milliamp. To find I total, we just use IR1 plus IR2 and plus IR3 and we get 15.55 milliamp.
A very good evening. I'm Osman Celestine, 241301789. Today, I represent Hartonian's formula and calculation by the triangles Ohm's law. As we can see on the slide, there's a formula to find voltage, current, and resistance. To find voltage, measurement for voltage is V equal IR. To find current, we close the I and we get the formula to find measurement current is I equal V per R. And to find resistance, we close R and we get the R to find measurement resistance is R equal V per I. And this is the calculation that have been used by triangles Ohm's law, V per I R. And as you can see, this is the calculation for R total for series, 44 kilo ohms. And for parallel circuit, R total of total is 0.884 kilo ohms. And the battery that I've been used for series and parallel circuit is 9 volt. And I total for series for measurement for series circuit is 6.08 ampere, and for parallel I total is 2.0 ampere. and to find resistance, we need to use measurement R equal V per I, and we get 1.5 ohms for series, and for parallel is 4.5 ohm. And at the bottom, we can see the calculation resistance one by one, R1, R2, and R3 for series and parallel. And same as for searching calculation for volt and current when you say one by one resistance R1, R2, and R3. And we can say that we can increase current by resisting the resistance, or we can reduce current by increase resistance. That means that series and parallel circuit that are low voltage, high resistance, and low current. That's all for all today. Thank you.
Hello, my name is Kavin Selvan, son of Parthiban, and my metric number is 241301788, and I'm from Electronic Network Design. So here we are finally in conclusion. To wrap up our presentation, let's revisit the key points about Ohm's law and its application in series and parallel circuits. Ohm's law, which states that V equals to IR, forms the foundation of electrical circuit analysis. It shows the simple yet powerful relationship between voltage, current, and resistance. We learned that in series circuits, the total resistance is the sum of individual resistance, while the current remains constant throughout the circuit. On the other hand, in parallel circuit, the total resistance is lower than the smaller resistor, as current divides among the branches while voltage stays constant. We also explored the Ohm's law triangle, a helpful tool for quickly solving for voltage, current, or resistance when the other two are known. In essence, Ohm's law helps us predict and understand how electricity behaves in different configurations. It's an essential principle for designing, troubleshooting, and optimizing electrical systems, from simple household circuits to advanced technologies. Thank you for your attention, and we hope this presentation helped you gain a deeper understanding of Ohm's law and its application. Thank you.
Yes.